Chemical reaction. When a substance undergoes a change to produce a new substance with different properties and composition, it is called a chemical reaction. For example, when iron filling and sulfur powder are heated together, they combine to form a new substance called iron sulfide. This is an example of a chemical reaction. Chemical change. The changes in which the chemical composition and properties of a substance change and one or more new substances are formed are called chemical changes. Examples are formation of curd, digestion of food, burning of wax candle, rusting of iron, and burning of a fuel. Characteristics of a chemical change. A chemical reaction is characterized by certain changes which take place during the transformation of a reactant to product. These include evolution of gas, change of color, formation of precipitate, energy changes, change of state, change of smell. Evolution of gas. In some chemical reaction, gases are evolved as product. The evolution of gas is shown by an upward arrow in a chemical reaction. Following example will prove the point. Example 1. When sodium carbonate solid is treated with hydrochloric acid, a brisk reaction takes place and a colorless gas, carbon dioxide, is evolved with sodium chloride and water as other product. Example 2. When ammonium chloride is heated strongly, it decomposes into two gases, hydrogen chloride and ammonia. Example 3. When zinc metal is treated with dilute sulfuric acid, hydrogen gases evolve. Example 4. When sodium nitrate crystals are heated strongly, they melt and liberate oxygen gas. Example 5. When copper sulfide is treated with hydrochloric acid, it gives off foul-smelling gas, hydrogen sulfide. Change of color. In some chemical reaction, the color changes when reactants are converted into products. Following example will prove that point. Example 1. When red lead oxide is heated strongly, it forms yellow colored lead monoxide and gives off oxygen gas. Example 2. When green color copper carbonate is heated strongly, it leaves behind a black residue of copper oxide and gives off carbon dioxide gas. When white lead nitrate crystals are heated strongly, they decompose to form yellow color lead monoxide and gives off reddish brown gas, nitrogen dioxide, along with oxygen gas. Formation of precipitate. When two solutions of soluble substances are mixed together, an insoluble solid substance called precipitate is formed. Precipitate is shown by downward arrow in a chemical reaction. Following example will prove the point. Example 1. When colorless potassium iodide solution react with colorless lead acetate solution, it forms potassium acetate solution and yellow precipitate of lead iodide. Example 2. When a colorless solution of silver nitrate is mixed with the colorless solution of sodium chloride, it forms sodium nitrate solution and white precipitate of silver chloride. Example 3. When solution of the ferrous sulfate, that is light green in color, is mixed with sodium hydroxide solution, which is colorless, it forms sodium sulfate solution and dirty green precipitate of ferrous hydroxide. Example 4. When lead nitrate colorless solution is mixed with potassium iodide colorless solution, it forms potassium nitrate solution and yellow precipitate of lead iodide. Energy change. Most of the chemical reactions take place either by the absorption or by the release of energy, generally in the form of heat energy. Exothermic reaction. The chemical reactions which proceed with the release of heat energy are called exothermic reaction. Following examples will prove the point. Example 1. When hydrochloric acid reacts with sodium hydroxide solution, it forms sodium chloride and water with the evolution of lot of heat. Example 2. When magnesium ribbon is heated from its tip in a Bunsen flame, it catches fire and burns with a dazzling white flame with the release of heat and light energy. The product form is magnesium oxide. Example 3. When a small piece of quicklime is placed in about 100 ml of water, the water becomes very hot and sometimes starts boiling. It is because calcium oxide reacts with water to form calcium hydroxide with the release of heat energy. Endothermic reactions. The chemical reactions which proceed with the absorption of heat energy are called endothermic reaction. Following examples will prove the point. When sodium bicarbonate is heated strongly, it forms sodium carbonate, steam and carbon dioxide gas. The reaction takes place only on heating, that is with the absorption of energy. Example 2. When limestone is heated, it absorbs energy and changes into calcium oxide and carbon dioxide. Change of state. In some chemical reaction, the physical state of the reactants get changed. The product have different physical state from that of reactants. Following example will prove the point. When hydrogen gas react with oxygen gas, it forms water, which is in the liquid state. Example 2. When ammonia gas react with hydrochloric acid gas, it forms ammonium chloride, which is in the solid state. Example 3. When solid red hot carbon reacts with sulfur vapors, it forms carbon disulfide, which is in liquid state. Change of smell. In certain chemical reactions, the smell of substances changes due to formation of new product. For example, when Sodium sulfide is heated with dilute hydrochloric acid. Sodium chloride and hydrogen sulfide are formed. Hydrogen sulfide has characteristic smell of rotten eggs. Chemical equation. The representation of a chemical reaction by using symbols and formula of the elements and compounds involved in it is called a chemical equation. Few terms used in writing a chemical equations are reactants. The substances which take part in a chemical reactions are called reactants. The reactants are always written on the left-hand side of a chemical equation. Products. The substance formed as a result of a chemical reaction are called products. The products are always written on the right-hand side of a chemical equation. A chemical equation consists of formula of reactants connected by a plus sign and an arrow followed by the formula of product connected by plus sign. The sign of arrow is read as to yield or to form. Explanation of chemical equation. Like symbols and formula, chemical equation conveys both qualitative and quantitative meaning. Let us consider the following example. The equation written can be interpreted qualitatively by saying that hydrogen reacts with oxygen to form water. The same equation can be interpreted quantitatively by saying that two molecules of hydrogen react with one molecule of oxygen to form two molecules of water. Or we can say that two volumes of hydrogen will completely react with one volume of oxygen to form two volumes of water. Chemical equation can be unbalanced and can be a balanced chemical equation. When a chemical equation is written in the term of symbols and formulae and the number of atoms of each element on the reactant side is not equal to the number of atoms of that element on the product side, it is an unbalanced equation. In example 1, we can see that the number of oxygen atom on the reactant side is 3, whereas on the product side is 4. Such type of equation is called unbalanced equation. When the number of atoms of each element is equal on both the sides, the chemical equation is called a balanced chemical equation. As in example 2, there are 2 sodium atoms, 2 nitrogen atoms and 6 oxygen atoms on each side. That is the number of atoms on the reactant side and the number of atoms of the element on the product sides are equal. Such equation is called a balanced equation. Prior knowledge for balancing a chemical equation. Before writing a chemical equation, we should have the following knowledge. Number 1, whether or not reaction take place between two or more given reactant. Second, one must know all the products formed during the chemical reaction. Third, one must know the correct symbol and formula of the reactant and products. The process of making the number of atoms of each element equal on both sides of an equation is called balancing of an equation. How to balance a chemical equation? It can be shown by an example. When ferric hydroxide reacts with dilute sulfuric acid, it forms ferric sulfate and water. This reaction can be written in the form of symbol and formula. But that equation is an unbalanced equation because the number of atoms of the element on the reactant and the product side are different. Iron atoms in the reactant side is 1, whereas in product side it is 2. Sulfur atoms in the reactant side is 1 and in the product side 3. Hydrogen atoms in the reactant side is 5, in product side 2. Oxygen atom in the reactant side is 7 and in the product side is 13. It is a totally unbalanced equation. Now to balance the equation one by one, we have to take an element and balance the number of atoms on the reactant and the product side and make them equal. We will start first by balancing iron atom. As we know, the number of atoms in the reactant side is 1 and in the product side the number of atoms of iron is 2. So to balance it on both the side, we multiply 2 with ferric hydroxide. When we multiply 2 with ferric hydroxide, so number of iron atom on the reactant side and the product sides become equal, that is 2. Now we balance the sulfur atom. As we know that atoms of sulfur on the reactant side is 1 and on the product side they are 3. So to balance it, we multiply 3 with sulfuric acid. When we multiply 3 with sulfuric acid, then the number of atoms of sulfur become equal in both the sides. Now we balance the hydrogen atom. Previously the hydrogen atom in the reactant side were 5 and in product side 2. But when we multiplied ferric hydroxide with 2 and sulfuric acid with 3, then the number of the atoms of the hydrogen in the reactant side become 12. Whereas in the product side they are same, that is 2. So to balance the number of atoms of hydrogen, we multiply water with 6 on the product side. When we multiply water with 6 on the product side, so number of atoms on both the side, that is reactant and the product side, becomes 12. Now the last element left to be balanced is oxygen. After balancing iron, sulfur and hydrogen, the number of oxygen atoms on the reactant sides are 18 and the number of the oxygen on the product side are also 18. That means the number of atoms are equal on both the side, that is reactant and the product. Thus, the equation becomes a balanced equation because the number of atoms of iron, sulfur, hydrogen and oxygen on the reactant as well as the product sides are equal.